Dear ladies and gentlemen, we prepared for you presentation about prostate cancer diagnostics, about cooperation in these diagnostics between immunochemistry and histology. Here is the schedule of the presentation. In the beginning, we will talk a bit about prostate cancer epidemiology. Then we will continue with the blood test, namely tumor markers, and then we will continue with the examination of the tissue. Here is a brief background. More than 1 million cases of prostate cancer are worldwide diagnosed every year, and the mortality is over 300,000 men per year. Here is the picture about incidence of prostate cancer worldwide. As you can see, the highest incidence is in developed countries. If we compare this picture, this map, with mortality, you can see that incidence and mortality don't correlate. The explanation is very easy. It is about level of diagnostics, about advanced healthcare. Here we can see current diagnostic tools. In the first line, blood test, tumor markers, then biopsy and histology testing, and then imaging techniques. For today, we will talk about these 2 points. Let me start with the blood tests. Blood tests, there are in the first line tumor markers. The basic tumor marker for prostate cancer is prostate specific antigen, PSA. PSA is an enzyme, member of kallikrein family. Biological function is semen liquefaction, and since 80s last century is PSA used as a tumor marker in prostate cancer diagnostics. Prostate specific antigen is a really very useful tool, but PSA is specific for prostate tissue but not for prostate cancer cells. We can see elevated PSA levels in prostate cancer cells, but also in benign prostatic hyperplasia or another benign diseases like acute and chronic prostatitis, etc. This is a relatively issue in the diagnostic process, and the solution is searching for new form of PSA which can help us to solve this unsatisfactory specificity. Here you can see the form of PSA which are present in the blood. Here at the left side you can see the total PSA, and in the 90s last century we started to measure also the free fraction of PSA, and it was second very good step in diagnostic of prostate cancer. This free fraction consists from next 3 subfraction, and here you can see this fraction pro PSA, and from this fraction is since 2010 used -2 pro PSA, which is very narrowly connected with cancer cells, prostate cancer cells. So, and here you can see the whole PSA panel. Currently we are able to measure total PSA, free PSA, From these two items, we are able to calculate percentage of free PSA. Here you can see the equation. Third parameter which can be measured is pro-PSA, and from these three tests we are able to calculate prostate health index phi. Here you can see also the equation. Pro-PSA is not measured in all samples. The indication is special, and pro-PSA is measured only when PSA, total PSA, is in the range between 2 and 10 microgram per liter. Then pro-PSA is measured and phi is calculated. And phi is very helpful tool in this gray zone. Here you can see ROC curve, and here you can see the red line belongs to phi, and phi is the best parameter to distinguishing between prostate cancer and benign diseases. Area under the curve is higher than 0.8. This is very good, very high value. Test procedure is very easy. For 3 tests, we need only 1 tube of venous blood. After separation, we used serum, and using automated chemiluminescent instrument are measured these 3 parameters: total PSA, free PSA, and pro-PSA, and also percentage of free PSA and phi is automatically calculated. Principle of this method is reaction between antigen and antibody. This is similar system like in lock and key. For this reaction you need 3 reagents: antibody against, for example, PSA molecule, antigen, this is for us in this case PSA molecule, and some signal which is measured and quantified. Here you can see the principle of the reaction. The reaction is called sandwich reaction, and really this is very similar to a real sandwich, which you can see here, because here this is the final position of the components in this reaction. Here you can see paramagnetic particle with first antibody against one antigen determinant of PSA molecule. Here you can see second antibody against different determinant of PSA molecule, and this really looks like sandwich, because one bread, second bread, cheese and ham, and here is signal molecule. This signal is enhanced and then measured and quantified. The results are reporting in microgram per liter. As you can see, PSA depends on age. Here are our reference ranges. Percentage of free PSA is reported in percentage, and phi is only number without units. Here you can see the diagnostic algorithm which is applied in the University Hospital in Pilsen. This diagnostic algorithm was created by clinicians from Department of Urology. As you can see, PSA and phi is included here in the first line. Then here you can see different type of imaging techniques, and in the middle of the algorithm is biopsy, because biopsy is absolutely necessary to next decision about patient. And here you can see a picture of the prostate with bioptic needles, 10 bioptic needles. This picture was created using Fusion software. And when we are talking about biopsy, this is the right time to invite next speaker, Professor Ondřej Hess from Department of Pathology.